I was a person who decided to introduce a completely alpha library into our production system. So you probably don't want to listen to me for my wisdom, but you might want to listen to me to the experience that we gained from applying Clojure spec, even was like sort of alpha 8, 9-ish, to about 15,000 lines of Clojure production code and kind of see what we learned. Now, this being not the first talk about spec, we can probably skip some of the details. And like, just to be sure, like everyone here knows what Clojure spec is. Hands up, like this. Yeah. Okay, so roughly, basically, just sort of a quick recap. The idea is that we could define something similar to regular expressions, only to use it to describe any arbitrary data structure. And this turns out to be a very powerful approach to how to describe your data. Now, the article where this first appeared is in itself a lovely piece of work, very easy to kind of to follow along. But, and this is what I want to kind of emphasize, is we also have kind of a live version available from the people who did the Clips live experimenting environment in the browser. They have this kind of wonderful blog post where they take you through all the kind of main ideas in the article, and you basically implement the basics of spec in, turns out, a couple of tens of lines. And it's really kind of enlightening also just to see this translation between the kind of world of mathematics and the kind of simple these ideas can then be turned into Clojure code. So even if you have a pretty good understanding of what's happening, I just kind of recommend you check it out because of this. Like, I was really kind of giddily just seeing how things come together and how like this beauty of Clojure really shines through with having this small kind of bits and pieces combined together and arrive kind of pretty amazing results. Right. So spec. Now there's a lot of kind of use cases were foreseen with spec. It should do validation, error reporting, destructuring, instrumentation, test generation, and so on and so on, so forth. And like, why am I listing all of these? And as you'll see, that actually there are even more use cases than this. But the thing is that it also kind of showcases the beauty of the design behind Clojure and something that's kind of, I think, present in many of the best Clojure libraries. And this kind of notion that to find really kind of the fundamental building blocks of what we're doing, we should first kind of strive to decompose our problem into the simplest bits and then build on top of that. Like this quote by Eric Norman might seem like very banal on one hand, but it's actually also very profound. This is exactly what the Clojure way of solving problems is. And spec is a wonderful example of this because it really decomplexes the problem into very small pieces, which then can see that not only that they combine in different ways, it also allows you to kind of just pick some bits and just use that. And so we, in one library, have so many very different venues of usage. So kind of to go through what our experience was, or first, like what I'll be talking about is kind of maybe slightly specific because it's mostly code that does stuff with data and with numbers. It's essentially our entire ETL pipeline and then various inference algorithms running on this, things like risk hedging, demand responsive pricing, packing, routing, and things like that. Also some internal BI tools, but those are kind of in the minority. So it's kind of not really a kind of a web app or something like that, but it's a very old school data crunching kind of thing. And this might also kind of change or cloud my valuation of kind of what things work and what didn't. Also, another thing I want to emphasize is that before going to spec, we were already using a prismatic schema, so it wasn't exactly that we've just kind of went head along into something new, but had a pretty good idea of what we're kind of looking for. And it's like, in other ways, spec is just kind of replacing schema, but I feel that kind of going forward, it's actually kind of the superior way of doing it, especially because I think that it achieves more with less. It's a slight difference, but once you kind of start using it, what would happen with schema is that you would kind of pretty quickly come to the sort of edges. While on the other hand, what happens with spec is it kind of found that you have more and more uses, and so it kind of just better fall out. So now kind of going forward, really don't we've already actually changed over completely from schema, and I'm just using spec, and I'm now also looking to use spec in kind of new different venues where we couldn't use schema beforehand. Right, so going, the first kind of and most obvious probably use case for schema is validation. Now, here just kind of a quick battle report. First, we went completely overboard and instrumented almost kind of all functions, but that really doesn't make sense. So, I think a sane compromise is to use it at API boundaries. I mean, even like with internal libraries, something like that, then it makes sense to have validation there, and obviously anything to do with kind of inputs, although in our case, that's not such a big thing. But I'm still kind of not entirely clear. So there is a question of just how to kind of then structure your code, where should schemas be something that goes alongside with your code, similar as how do you do it, let's say, in a kind of a Haskell or something, or should schemas be completely separate? This is something I'm still kind of struggling with, just what's the better way of doing it. Now, but then also what you get is not just kind of another way of validating things, but actually, if you just look at the output, when something goes wrong from schema, what you actually get is a structured error. And this is kind of a deceptively simple thing that has very great implications. Now, a lot of the potential, I think, is not actually being taken advantage of. But once you have structured errors, there's things like having a database of errors and just kind of searching for similar occurrences becomes way easier, and you can actually have a better semantic understanding of what went wrong. And also, you can kind of do things like maybe something similar than with what you have in Common Lisp with restarts, where you actually have enough information, enough context already in your error that you have a better idea of what to go, where to proceed from, rather than being kind of forced to parse some error message or something like that. So just this notion of, again, having data at another place where previously it wasn't as well structured is kind of a powerful thing. And I think that going forward, there's going to be these like small changes in how we do closure that are going to have a big impact on the closure ecosystem and just how we're using closure in years to come. Also, just in terms of where to put schema, one thing that I found useful, especially when doing kind of very interactive programming, either in a REPL or a notebook or something, is kind of this notion that it's good to fail fast. Because now we all know that stack traces in Clojure are kind of at best an acquired taste. And it kind of really sucks to kind of then try to figure out where exactly things went wrong when you have this literally hundreds of lines of stack traces. And like what happens with schema is, first of all, you kind of get a pretty nice description of what went wrong, but also, if you're kind of diligent with putting schema around, things are going to kind of explode sooner, and this greatly simplifies just kind of figuring out and reconstructing what actually went wrong. So this is another reason why, yeah, you should do that kind of at least the API boundaries, where it's kind of most common that you're kind of using something wrong or aren't anticipating kind of some form of input or something like that. And then there is also kind of related to this is that, like, I love nil punning in Clojure, but it also leads to some kind of very subtle bugs. And again, having spec to kind of figure out that, no, we really shouldn't have a nil here or something like that is helpful, especially on those, because there's still, like, Clojure is pretty lenient and pretty good how it handles nils flowing everything around, but there are some kind of areas where nil just doesn't work, even though it might expect it does, and things then go wrong in weird ways that aren't necessarily always quite always obvious. So again, it's good to have some validation in place just to actually speed up development. And this is something that's kind of been counterintuitive for me, that it actually makes sense just from the perspective of doing this very dynamic development, that it makes sense to actually write some schemas up front, but actually then once you play with your code and experiment, it does save you time. And again, a similar thing is if you are big on using multiple arrays, again, it's very easy to do something wrong and not pass, maybe omit some argument that you're expecting. And again, error messages are normally kind of pretty hard to figure out what went wrong, so just know something is not a sec that should be, and they're like, how did this happen? Well, here with schema, you can then, with spec, you get a very clear understanding, okay, this is, I've misused or didn't comply with the arrays expected. Right. The next thing, still on the topic of validation, is that once we get messages, also what spec allows you to do is to have pluggable explanations via the explain out mechanism. And this is a very good thing, especially, again, in a more interactive setting. And if you are training maybe new people to get up to speed with Clojure, it immensely helps if you just sort of pack all the common mistakes and just anticipate them and have very nice error messages. It's something that, like, if we look sort of slightly beyond our borders into the land of maybe Rust or Elm, those guys have like amazingly well thought out error messages. And what spec gives me hope is that something similar is slowly going to happen in Clojure land as well. And again, you can also not just have error explanations of what went wrong, but also just based on, if you kind of parse what went wrong, you can oftentimes also provide hints of what might be the corrective way. Now, sadly, this is a great idea, but I don't kind of see it as being fully developed because it has kind of a strange omission or limitation, which is that you essentially just have one function for all, and this becomes problematic if you have trying to have, for instance, each library provide some of its own explanations, and then this just doesn't kind of mesh well together. And you also don't know which spec actually triggered the error. You just know what went wrong, but you don't know which spec this belongs to. Now, both of those things kind of then preclude any sort of having an extensibility mechanism where you could just progressively define more and more of these explanations. But again, this is alpha code, so I'm hoping that more of this will be developed as time goes on. Right, next thing is destructuring. Here, this was like one of the unexpected areas where I was kind of amazed with spec and started using it even like in just kind of small bits and pieces around all my projects. Because what it does is, in a way, it destructures destructuring in a sense that you have this kind of mechanism of pulling apart even very complex structures, much more complex than what you could do with normal destructuring. And you can also name very precisely parts in them. So this really allows you to reach into a structure and then extract some part in a named manner. And this allows you to separate better the data description and the transformations. And I think that this is kind of important. I'm sure you could say, oh, but you can just have a function to do this already and kind of separate the two. Yes, but it also, like, what the nice thing with spec is that then it gives you this like kind of clear semantic comment on it that this is kind of something different. It's not just kind of some function, because a problem that I sometimes have when kind of just looking critically back on the code that I wrote is that some of the kind of the small functions that we write are just kind of, they don't really make sense on their own. They're just like, they only make sense in the context of them being called by another function. And this, I think, is kind of problematic once you return to your code or if you collaborate with other people. And with what happens with spec is that you have this kind of clear delineation between code that actually does something and just kind of this various transformations that you do. And I think that this kind of aids in understanding of what's going on in code. But obviously, this is something that right now is just my hypothesis. It's going to need way more time and more people using spec to see if this is actually the case. Just in terms of kind of usage, it also kind of at first I thought that this destructuring done with spec is just a superior way rather to using core.match, but then I was going to use it more and more. It actually complements it very well. And now a pattern that I'm often using is spec in combination with either case, and they're just dispatching essentially on the tags that you get from conform, or using core match for some more complex things. And those things play very well together, especially because this is dynamic that you have kind of named parts that you can latch onto. Right. Continuing this notion of transforming data, there's also what I call data macros, or I don't call it, but I stole the idea of Juxt guys, where I read this idea first on their blog. And the idea is that it oftentimes kind of makes sense to provide this kind of recursive transformations of data into one canonical form. And this kind of, again, you can then split the sort of the interface part or your DSL part from the actual logic of then doing something like that. And this allows you to be way more lenient with what you admit in terms of input, and still don't have to kind of figure out all the corner cases. So you just have essentially data that can transform itself. And doing it in a kind of a macro-like way. What's nice about this, that there's kind of this inversion that the macro mechanism, and be it like the code macro that we know, or something like you can do with spec, or even you could do beforehand with schema, is that you then don't have to kind of walk the tree and do transformations, but actually get this tree walking and recursive transformations for free just based on how the mechanism is implemented. And that, again, kind of greatly simplifies what's going on and allows much better composability of different things together, and you don't have to account for all those instances in your parsing code. So in essence, what this kind of notion of data macros allows you is to do more without using the actual code macros. And this, I think, it's like, I know it's kind of controversial, and like we Lisp people should be very proud of our macro heritage, but oftentimes, like a macro is, I see it as a code smell. So there are some times where they are very useful in things like spec, for instance, or async or something like that, but oftentimes you don't really need them, and you do pay a hefty price in terms of how well things then compose. While using some mechanism like data macros, you don't have this problem, because it allows you to have just kind of data that self-transforms, and we know that if there's one thing that Clojure is good at, is transforming data. So you can just have bigger chunks of your program defined in terms of data and work on data, and this is where Clojure shines. So a quick example of this, just to get you a better idea of what I'm talking about, is like we want, and this is from some library I wrote to do data manipulation, and the idea is that we want some kind of quite clean API of doing filtering, but we also want to kind of have very complex things been happening in behind the scenes. And the thing is that what you see here is this is completely just functions and data describing the computation. You don't need any macros, even though it's kind of relatively user-friendly and concise description. And then what happens is that just by using spec in this capacity as for data macros, it transforms into something completely ungodly that you see below that you would never want to write manually. And just in terms of, like, it takes essentially a screen of code to define all the transformations that do this. And probably, like, once maybe some more tooling around and libraries around spec can available, we'll probably be able to do something like this in even a more succinct way. But even now, it's pretty clear what's going on. And the nice thing is that you kind of can separate all the kind of components and define just transformations of each, and don't really have to worry all that much about how they can then combine together. Rather, you can then combine them in any way you want, and just like all transformations just work. And also, another nice thing with spec is that because you're working with keywords, you don't have to worry that much about the order of defined things, which is a nice bonus. So now we come to kind of probably what spec is the poster child for testing, or rather more specifically the prototype-based or generative testing. And here I have to say that this, like, our experience was kind of mixed, because on paper obviously it sounds just like amazing, but there also has some serious limitations if you work with, for instance, sequences which have some internal structure. Let's say if you're working with time series, it's kind of pretty awkward right now to define a generator to emit a time series which has some sort of correlation with its previous states. And also, like, there's no elegant way of doing generative testing for very generic high-order functions, something like map, where it's kind of then hard to figure out what kind of function to generate, and it's hard to strike the right balance between being very generic and being like solving for a specific case. But one thing that surprised me, this was actually the reason why we went so boldly ahead with implementing spec, is that it uncovered very soon some numerical instabilities. Now, how many of you know what a numerical instability is? Just a few. OK, so the problem is that, like, when you're doing math and if you're using floating points, it might happen that you're going to be dividing something very small with something very small, and that, and you hit the limitations of how precise the float point numbers are, and then weird things can start to happen. And this leads to very, very subtle bugs, because your algorithm generally works, but there might be some combination of inputs where the whole thing just explodes or makes some nonsensical results. And spec actually found 2 such bugs in our production code, which was like, wow. And this is something that then led me to wanting to explore this more, because this is something that's really, like, even if you're using some very bondage and discipline type system, it's still kind of hard to encode all the invariants to catch all the numerical instability. So here spec just doing essentially throwing random things at it and found some of those things. So that was very unexpected and a very powerful thing. And obviously, another thing that might not be immediately obvious is that you can use the exercise between the generating ability of spec just for mocking. So you, again, gain something more with just defining your spec. Now moving away from the kind of standard things that you can do with Clojure, with spec, is that what I like to call queryable data descriptions. Basically, as I said, spec, when it boils down to it, is a way to describe your data. And this can be very powerful if you, for instance, then throw all these descriptions into a graph and have some relations between it. And also, like previously, there was a question of kind of how to handle migrations and things like that. Like how we do it is we have a datomic field with our specs kind of parsed with different, how it composes with different things, and then you can also just kind of define various relations of how it kind of moves through time or have snapshots of how my spec move around. So again, because everything is just data, you can actually interact with your type system at runtime, and this is a very, very powerful thing. Like here, only thing that's kind of hurting right now is that you can't have, can't have inline docs with your schemas, which kind of limit then this self-documenting potential. But kind of going forward, again, this is, I think, where spec is going to be a cornerstone of what we do is exactly in just kind of describing all the data that flows around through our system. Now, to be kind of more concrete, the pipeline that we have is essentially various events come in, then we have Onyx kind of doing all the shuffling of data around. We throw all the things into Kafka, and then what we do in this kind of the core thing, we then are very aggressive in building materialized views, meaning like we kind of pre-compute and do various enrichments and so forth of our data and combine it in ways that we think that are going to be useful when then doing analysis. So because the thing is, like, if you ask any data scientist, or maybe after they've had a drink or two, they'll admit that it's still kind of the best thing to do all the analysis on your computer rather than having to run it on some cluster or whatever. So it does help in terms of productivity if you can do the most computations you can on your local machine. But this also means that you have to be kind of smart about which data do you pull in. And materialized views should kind of, in theory, solve this problem, but they then introduce a different set of problems, which is that they're never exactly what you need, and then you still have to revert to the raw data or do some hideous joins or something like that, and defeating the purpose. But what we're doing instead is that we kind of defined this ontology of data going in. This is using spec. And then we have rules on top of that, how to generate views automatically and combine them to provide new views. And all this can be done just like in terms of data. So we describe not only the computations that are being done, so how these descriptions are in Onyx, and some of it is in spec, but also we then have this kind of recursive rules of how, when a new view is produced, it can actually be used as an input to produce something new and new. So we have this kind of constant flow of kind of trying to build new ways to combine our data, and also do things on it like some statistical analysis to find out if we have seasonality, and if we have seasonality, then you want to do aggregation in one way, and you want to do outlier remover and things like that. Again, like what previously, we had a lot of this functionality already built previously, but it was this unmaintainable mess out of various scripts that did this thing, and that just kind of didn't compose obviously very well, and it was kind of hard to recycle, and we're repeating the same thing over and over again. And kind of with spec, you have a much clearer way of doing this. And also, you can just kind of interrogate all the running parts of the system as the system is running, and this kind of gives you a lot of both power and confidence in what's going on. Now, having said that, I think that there's another guiding principle with Clojure is kind of this simple first and then easy. And with spec, I think that the simple part has been nailed, and it's really kind of a very simple language describing data with immense power, but the easy part is maybe not always there. There's kind of some rough edges, and many things are maybe more verbose than need to be. Now, I've already tried to scratch some of our itches and did some kind of small macros to ease up the most common use cases. But I think that this is kind of one of those things where a discussion needs to be this kind of distributed informal discussion within the entire community of kind of how we go forward, what's going to be the idiomatic way of using spec. Like what things require just new libraries, and where can we just settle on some idioms and use that and things like that. So this also one of the reasons why I'm giving this talk is just kind of hoping to spur this discussion and see how you are using spec, or maybe like what are your problems or views on it, and just try to arrive at this idiomatic way of using spec and understanding of what spec is. Now, some other open questions, like I've already outlined, like for instance, another big thing that I'm not set upon is, should you inline your specs with your code, or should it be completely separate? Obviously, we need way more tooling to take advantage of spec from all kind of sides of the stack. It just brings so much to the table that it really kind of makes sense to try to use it most. And then there are also just lovely projects that hint at what's possible. For instance, Ambrose, the developer behind type closures, now was experimenting with using spec, like these interactions between spec and typed closure, and what things can be kind of inferred from spec and vice versa. And this is terribly exciting. And also, if we look again beyond our borders, for instance, in Haskell, you have this library that does that infers invariants from the functions you give it in. And this is again something that we can also do using the generative abilities of spec. So in essence, the future is kind of very bright for spec. And just now to wrap it up, basically like my 4 favorites in using spec, and what you'll notice is that none of them are kind of those things that are sort of were at the forefront of spec when it was introduced, but my 4 favorites are data macros, using spec for destructuring, using spec for this kind of as a queryable data description, and last but not least, finally having structured errors on which you can then do inference and having them be something more useful than just this kind of pain and hassle. So with this in mind, I yield the floor to any questions that you might have. Thank you.
Anybody have any questions? No. We're all getting a little bit sleepy. Or we're all just totally amazed by all the things that we've happened today and yesterday. Oh, question, there we go. Oh.
Hello. I was interested to see you talking about using spec at API boundaries and also saying that you'd found some bugs. There's more of a suggestion than a question. Spec's quite good around date-time functions. I found some bugs in my own code there, date time being notoriously difficult. So that's a good place to use spec, I've found. Sorry, that's not a question.
No, and as I said, I way rather than just having some questions is to be this as a discussion of kind of where we see spec having value or something that surprised you either in a positive way or negative way with using spec. But yes, please.
Thank you for your talk. So I don't know spec that well, but I wondered, you mentioned case or core match. With the structuring, do you have like a concrete example of how you've used it? Do you mean branching on a particular attribute of your?
Yeah, basically doing the conforming, meaning kind of using the spec mechanism to name and extract various elements, and then what you get is essentially a much flatter representation of your data, and then using match on the parts of this. Like, it's something that doesn't come up that often, but when it does, it amazingly simplifies the code. So it's something that it's worth keeping in mind for that kind of the hairy cases where otherwise we have so many kind of different fetchings of or reaching into the data structure or something like that. I'm guessing maybe even like something like Spectre, which is another library to reach out into the data structures, might work well here, but I haven't used it. But again, it kind of seems promising in this regard.
Thank you.
Any more questions? Anybody? No. Everybody's looking forward to using spec when they get back to work on Monday morning, I think. Thank you very much, Simon.